Welcome to this video. Today we are going to solve a very interesting problem in Python, anagrams. We'll first understand what an anagram is. Then look at the algorithms using both built-in methods and non-built-in methods and solve them programmatically and write unit tests. There is also a challenge at the end for you. So let's get started. So first, what is an anagram? For an input of a pair of words or phrases, an anagram is when one word or phrase can be formed by rearranging the letters of the other. If two words or two phrases have the same letters in the same frequency, they are anagrams. These are the examples. Earth and heart. Heart has the same characters as that of earth, and they are called anagrams. Surprisingly, we also have 11 plus 2, anagram of 12 plus 1, and vice versa. We will work on two solutions. One using built-in method, another without using it. Why are we having two different solutions? Solution using built-in methods gives us knowledge about the method offered by the language itself to perform the task. And solution without using built-in method allows us to practice our logical thinking. So having both solution gives us knowledge of built-in methods and strong logical foundation. Let us into algorithm using built-in method. We take two strings S1 and S2. We sort the characters of both strings which gets written like this. So we are comparing the sorted results. If they are equal, they are anagrams. Otherwise, it is not an anagram. Let us take an example. We have an earth and heart. We are comparing it. It gets sorted in the ascending order. So if they are equal, so it is called valid. Otherwise, it's not an anagram. This is all about an algorithm about built-in method, using built-in method. Let us get into the algorithm using non-built-in method. In the first step, what we do is we get the first string. We create a dictionary with key value pairs, with key as the character and the value as the number of occurrences of the character in the string. This is all about the first string. For the second string, for each character in the second string, we are checking in the dictionary whether it is there. If the character is not found, we say it is not an anagram. If the character is found, what we do is we decrement the value of the key. If the key value of the character is 0, we remove the character from the dictionary. At last, we check if the dictionary has no key value pairs. There are no key value pairs, it means it is an anagram because it gets decremented, it becomes 0, we remove the key altogether from the dictionary. So if dictionary has any key value pair left, we say it is not an anagram. Let us see some examples of it. Let us see a valid case. We have earth. We have created a dictionary like this. So second string, when you are sending an heart, which is anagram of earth, see H, the character H is there. So we decrement it. So since it has become 0, we remove it altogether from the dictionary. It has become like this when H comes in. Similarly for E, similarly for A, and so on and so forth. At last, dictionary becomes empty. So when we check the length of the dictionary, it is 0. So we say it is an invalid anagram. This is all about valid case. Let us see invalid case. Invalid case in the sense we have first string earth. We have made up a dictionary. Second string, when P comes, it checks whether this is available in the dictionary. It is not available, so it returns false, which means it is not an anagram. Let us see the solution and solve it programmatically. This is all about it. This is an inbuilt method function which returns a sorted version of the string, which is a list actually. This list is compared with this list, and if it is equal, it becomes an anagram. Otherwise, it is not an anagram. This is all about programmatical implementation of the algorithms we have discussed. So we create a dictionary here. For each character, we have a value 1, and if it is more than, with the occurrence of the character is more than once, we increment it. Similarly, this is creating a dictionary, and for the second string, we check again with the dictionary created in the loop of the first string. So for each character, we check if it is there. If it is not there, we are returning false, which means it is not an anagram. If it is there, we decrement it. If the value is 0 for any of the characters, we remove it. At last, we check whether the count is 0. If it is 0, it means it is an anagram. So in short, what we do is, for the first string, we create a dictionary. For the second string, we destruct the dictionary, which means we remove the key value pairs. At last, we check whether no key value pair exists for this dictionary. If it is so, we say it is a valid anagram. This is all about it. We also have written a unit test. We have write our own class which extends the inbuilt class. We have written 4 functions which test our built-in methods and non-built-in method. For each case, we have built-in method and true scenario, we have one method. Built-in method and false scenario, we have another function. Similarly for non-built-in also. This is all about it. What we have seen is, we have seen algorithms for built-in method and non-built-in methods. We have solved it using programmatically, and finally we have written unit test. What is the challenge? We'll see the challenge now. When you check this evil and while, it returns false. Similarly, if I do this second line of the statement, it also returns false. It should actually be anagrams, right? Can you figure out why the code is failing here and make the necessary change? Drop your solution in the comments below. Thanks for watching. Have a nice day.